Good day, learners. My name is Sadiq Al-Hatujai. You are welcome to the second segment of the lesson. You remember the topic is matrices. I will continue from where I stopped in the first segment of the lesson. Today, we are going to see the transpose of a matrices, or the transpose of a metric. The transpose of a metric is obtained if the rows and the columns are interchanged. What we mean here, when you are asked to find the transpose of a matrix, all you need to do, you interchange the first row with the first to be the first column, second row to be your second column, then third row to be your third column. That is in the case of a 3 by 3 matrix. The new matrix so formed is now the transpose of the original matrix or the transpose of the given matrix. For example, if A is the original matrix, its transpose is denoted by A raised to the power of T. The T is superscript. Example 1. If A is a matrix with first row 4, 6, 7, 9, 2, and 5, then it transpose the first row in A will now be our first column. You change it to be the first column, that is 4 and 6. Now first row in A becomes the first column. Then second row 7 and 9 will now be the second column, that is 7 and 9. Then third row 2 and 5 will now be the third column, 2 and 5. Therefore, A transpose is a matrix with column 4, 6, 7, 9, 2, and 5. Example 2, if M is a matrix with elements in the first row, -2, 8, second row, -3, 5, then the transpose of matrix M is -2, 8. The first row in M will now be the first column, which is -2 and 8. Then second row in matrix M will be the second column, that is -3 and 5. Therefore, the transpose of matrix M is a matrix with a column -2, 8, 3, and 5. Next is to see the determinant of a 2 by 2 matrix. We said let A be a matrix with elements in the first row A, B, C, and D. This is a 2 by 2 matrix. Remember, in the first class I explained what a 2 by 2 matrix is. A matrix with 2 rows and 2 columns is referred to as a 2 by 2 matrix. Then the determinant of A, written as A determinant or det A, is obtained if you multiply the first number in the first row of matrix A times second number in the second row, that is A times D, minus C times B. It is here A times B minus C times D. When you multiply A times D, you have AD. C times D, you have CD. Now let's apply this rule to solve a particular problem under the determinant of a 2 by 2 matrix. Example, we said let Y be a matrix of element in the first row, 2, 3, second row, 1, and 5. Then its determinant, take note, if you are evaluating a determinant of a matrix, the brackets under the given matrix will now change to 2 vertical lines, meaning you are now evaluating the determinant. Therefore, the determinant of the matrix 2, 3, 1, and 5, as I said, the first number in the first row, that is 2, we multiply the second number in the second row, which is 5, then you have 2 times 5, 2 times 5 is here, then minus, this negative sign is for the evaluation of the determinant of a 2 by 2 matrix. Next is to multiply the first number in the first row times the second number in the first row, that is 1 times 3. Now upon multiplication, 2 times 5 is 10, then 1 times 3 is 3. Now 10 minus 3, you have 7. Therefore, 7 is the determinant of the given matrix. Next, we are to see example 2. Students, you should take note of this important example. We said, find the value of P for which the determinant is P, 4, minus 2, 5 equals to 18. Initially, all the matrices we have discussed so far, it is a matrix with a complete figure. Now we have a variable, P, and we are asked to find the value of P. That is, what is the value of P? So the same way you evaluate the determinant of the first example, you will do it same way here. That is, you multiply P times 5 minus 2 times 4. Take note, when you multiply 5 times P, you have 5P. Then minus, this first minus is for the evaluation of the determinant. Then when you multiply minus 2 times 4, you have minus 8. Equals to what? 18 is given from the question. Here, minus times minus, the sign will change to what? To positive, that is plus. Then you have 5P plus 8 equals to 18. You collect like times. Then you have 5P equals to 18. Initially, this is positive 8. 8 here is positive. If 8 crosses the equality sign, then it will be negative. Then we have 5P equals to 18 minus 8. 18 minus 8, you have 10. So the next step is 5P equals to 10. When you divide both sides by the coefficient of P, which is 5, because we are finding the value of P, then we have to divide both sides by the coefficient of P, which is 5. Therefore, 5P divided by 5 equals to 10 divided by 5. 5 at the denominator will cancel 5 at the numerator. You will now be left with what? With P only. Then 10 divided by 5, you have 2. Therefore, the value of P is what? Is 2, meaning the original value here is 2. Next, we are going to see a standard SSCE question on how to evaluate the determinant of a 2 by 2 matrix. This is a question, NACO 2019. The question says, find the positive value of x for which the determinant is given as 2x, 4 minus x, and 3x equals to 66. Now we'll evaluate the determinant just as the way we did the first and second example. We multiply 2x times 3x. Then we multiply minus x times 4. Here 2x times 3x minus, this minus is for the evaluation of the determinant. Then this minus x is for the elements in this determinant. Here 2x times 3x, when you multiply 2 times 3, you have 6. X times x, you have x raised to a power of 2. Then minus times minus is plus. Here you have plus. Then 4 times x, you have 4x, and this is equals to 66. Next is 6x squared plus 4x. This 66 at the right hand side is positive. If it crosses the equality sign to the left hand side, it will change to negative. Therefore, we have 6x squared plus 4x minus 66 equals to 0. And this gives you a standard quadratic equation. Now, you apply the knowledge of quadratic equation. The methods that do exist in solving quadratic equations are 4. One, we have the formula method. Second, we have completing the square method. We have the factorization method. Then we have the graphical method. Whichever one you use, it will serve the purpose. So this is a standard quadratic equation, as I said. 6x squared plus 4x minus 6 equals to 0. Now we can simplify this equation because 2 is common. 2 can go into 6, it can go into 4, and it can go into 66. Therefore, when we divide through by 2, 6 will reduce to 3, 4 will reduce to 2, and 66 will reduce to 33. Now, we use factorization method. Remember I said you can use completing the square method, you can use formula method, you can use graphical method. Now by factorization, 3x squared plus 9x plus 11x minus 3. One may ask himself, how did I arrive at minus 9x plus 11x? You go back to the original quadratic equation, which is 3x squared plus 6x minus 33. Since we are applying factorization methods, you must consider the coefficient of x squared. Since the coefficient of x squared is greater than 1, then you have to multiply the coefficient of x squared times the constant, which is minus 33. And upon multiplication, 3 times minus 33, you will have minus 99. Now you look for factors of minus 99. What I mean by factors of 99, the numbers that will go into 99 will divide 99 without remainder. We have 9, we have 11, we have 3, and we also have 33. But the most important thing you must know based on these factors, we want the factors that if you multiply them together, the two factors, if you multiply the two factors, you will have the constant number, which is 99. And if you add the numbers, you should be able to have the middle term. Now take, let's say, 33 and 3. If you multiply 33 and 3, you have 99. But this is 33, not 99. And if you add 33 plus 3, then you have 36. And we want 2, not 36. Then you go to the next factor, which is 9 and 11. When you multiply 9 and 11, you have 99, of course. But 9 plus 11 is 20. But we want 2, that is the middle term, if we add the factors. Here, what you will do, you change the sign of one of the values. You either place minus to 9 or to 11. For example, here we said 9 minus 9 times 11 will have minus 99. That is the multiplication, the product of 3 and minus 33. Minus 9 plus 11, it will give you the middle term, which is 2. Because minus 9 plus 11 is the same thing as 11 minus 9, which is what? 2. So here we have 3x squared minus 9x plus 11x minus 33. Minus 9x plus 11x is plus 2x. That is the middle term. Take it. Then now I can group this. That is 3x squared minus 9x. Enclose them in a bracket. The positive sign, it is here. Then 11x minus 33x minus 33. Enclose them two in a bracket. Now looking at this, the first bracket, there is something in common. 3 and x are common because we have x here and we also have x here. We have 3 and we also have 3 in 9. So we can factor 3x out. If we factor 3x out, we will be left with x minus 3. In the sense that if you multiply 3x times x, you will arrive at 3x squared. 3x times minus 3, you have minus 9x. That is the idea. Then next, the next bracket, 11 is common. You factor 11 out. 11 times x, you have 11x. 11 times minus 3, you have minus 33. Therefore, you take the factor 3x and 11, enclose them in a bracket. Then looking at these two brackets, they are the same. X minus 3, x minus 3. Take note in factorization, these two brackets must be the same. In whatever condition, the two brackets must be the same. Don't change the variable to this x and make this one to be y, or this plus, this minus, this 3, this 6. No, the two brackets must be the same. Having this, you have 3x plus 11 or times x minus 3 equals to 0. What this statement is saying, either the first bracket is the one equals to 0, or the second bracket is the one equals to 0. That is 3x plus 11 equals to 0, or x minus 11 equals to 0. Therefore, 3x equals to, if plus 11 here, cross the equality sign, it will be minus 11. And in the second bracket, if minus x, cross the equality sign to the right hand side, it will be 3 positive, that is plus 3. Now this is 3x equals to minus 11. You divide both sides by the coefficient of x, which is 3. So here, 3x over 3, 3 at the denominator will cancel 3 at the numerator. You will be left with x only. And you have minus 11 divided by 3. Then at the second side, x minus 3 equals to 0. If x cross the equality sign, it will be what? X equals to 3. Remember, the question says, find the positive value of x. These are the two solutions of this equation. In any polynomial equation of degree 2, which is quadratic equation, you must have two solutions. The first solution here is minus 11 over x, minus 11 divided by 3. And the second solution is 3. And the question says the positive value. So x equals to minus 11 over 3 is not positive, it's negative. But x equals to 3 is positive. Therefore, the positive value of this determinant is what? Is 3. Therefore, the answer of this is what? Is 3, which is the positive. Next is to see the inverse of a 2 by 2 matrix. The inverse of a matrix P is another matrix Q of the same order, meaning if matrix P is 2 by 2, then matrix Q must also be 2 by 2. And what this is saying, if you multiply P times Q, you should be able to have an identity matrix. I explain identity matrix under types of matrices. Identity of 2 by 2 matrix, you have element 1, 0, 0, 1. That is the entries of that matrix. And likewise, if you multiply Q times P, because multiplication is commutative. If you said 1 times 2, you will have 2. If you said 2 times 1, still the result is 2. Therefore, multiplication is commutative. In this regard, if you multiply P times Q, its inverse, you should be able to have identity matrix, which is I. Or if you multiply Q, which is the identity, which is the inverse, times the original matrix P, you should also be able to have an identity matrix of a 2 by 2. And you should take note, I is the identity matrix is donated by letter I. Let's take an example. First example says, find the inverse of the following. Find the inverse of the following. A is a matrix with first row of element 4, 2, and second row is 2 and 1. B is another matrix with element in the first row 8, 5, second row 3 and 2. Now we are asked to find the inverse of this matrix. Whenever you are asked to find the inverse of a matrix, all you need to do first is to evaluate the determinant of that given matrix. If the determinant is 0, then you don't need to go further. It has no inverse. But if the determinant is not 0, is greater than 1, is greater than 0, then it is what? It has an inverse. For example, in the first matrix with element 4, 2, 2 and 1, we assume that let R be the name of this matrix with element 4, 2, 2 and 1. Then a determinant, you just apply the idea of the determinant we just did. You multiply 4 times 2, then minus 2 times 1. 4 times 1 is 4, and 2 times 1 is 4. When you subtract 4 minus 4 is 0. So therefore, this matrix has no inverse. You don't need to go further. That is, there is no inverse for this matrix. The matrix is what? Is singular because its determinant is 0. So once you evaluate the determinant of a matrix and you find that the determinant is 0, then it is a singular matrix, therefore it has no inverse. B, we said let B be a matrix with row of elements. In the first row we have 8, we have 5. Second row 3 and 2. Now we first evaluate the determinant of the given matrix. That is 8 times 2 minus 3 times 5. 8 times 2 is 16. 3 times 5 is 15. When you subtract 16 minus 5, you will have 1. So therefore, this matrix has an inverse. So the inverse of a matrix written as B inverse equals to 1 over B determinant, that is the determinant of the given matrix, times the adjoint of B. So in a simple way, to find the adjoint of a matrix, that is 2 by 2 matrix, all you need to do is to swap the first number in the first row and the second number in the second row. That is, they will interchange their position. 2 will take the position of 8, and 8 will take the position of 2. Then you multiply the remaining element, that is 3 and 5, by minus 1. So the value or the sign of 3 and 5 will not change to negative. That is, the determinant of B is 1. So here we have 1 over 1. 1 at the denominator is the determinant of what? Of matrix B. And 2 minus 5 minus 3 and 8 is the adjoint of B. Now if you divide 1 divided by 1, you have 1. Isn't it? If you multiply this metric by 1, the result will not change. So you have 2 minus 5 minus 3 and 0 as the inverse of the given matrix B. Now to end the lesson, I have some assignments for you. Make sure you try it. The first one is find the question number 1A, find the inverse of a matrix with element in the first row 5, 3, second row 3 and 2. B, find the value of M for which the determinant, the first row is element M minus 2 and the second row is 3 and 2 equals to 16. Question number 2, find the product of the first metric is a row metric, is a row matrix with element 2, 3 and 1, and a column matrix with single column of elements 5, 6 and 7, and this is SSCE question 2015. Question number 3, given that matrix M is of elements in the first row 2, 3, second row 1 and 4, and matrix M is of elements in the first row minus 1, 2, in the second row minus 2 and minus 4. Find 2M minus N. This is also SSCE question 2019. I will take the questions again. Question number 1A, find the inverse of the matrix. First row 5, 3. Second row 3, 2. Number 1B, find the value of M for which the determinant In the determinant, the first row of element is m and minus 2. Second row is 3 and 2, and everything is equals to 16. Question number 2, find the product of the first metric. There is row matrix because it has single row of elements. That is 2, 3, and 1. That is the element. And the second matrix is column matrix with single column of elements 5, 6, and 7. It is SSCE 2015 question. Question number 3, given that M is a matrix of element in the first row, 2 and 3, second row 1 and 4, and N is another matrix of elements minus 1, 2, second row minus 2, minus 4. Find 2M minus N. It is also SSCE 2019. Thank you for listening. If you have any problem, you can contact me. There, this number 080-6226-4336. Again, 080-6226-4336. Thank you.